Okay, so next we'll start with the other problem. So here the bodies are connected to each other. So the question is, what value of P in the system shown in figure to cause the motion of 500 Newton block to the right side? Okay, so motion is taking in this direction. We need to find the value of P. Okay, to the right side. Assume that the pulley is smooth. The pulley is smooth here. That means it is frictionless, and the coefficient of friction mu at all contact surfaces 0.20. So it's a 60 degree, so it's 700 Newton, this is 500 Newtons. Okay, so first we'll consider the FBD of 700 Newton. Okay, we'll find the tension force which is acting in this rope. Okay, using this tension we'll find the value of P. Okay, so first we'll consider FBD of this 700 Newton. So I have drawn here. So this is the inclined surface and acting at an 60 degree with horizontal. So this is a 750 Newton block. 750 Newton block. So this is a tension force. So 1 second. So as you see here, as there is a rope here, so in every flexible material there exists a tension force. Tension force means acting away from the joint. So tension force will be acting like this. So as a motion is taking in this direction, right? So you can see here the motion is taking in this direction. As this moves in this direction, this block moves in this direction. So motion is taking in this direction, that means frictional force acts in the opposite direction. So frictional force is acting in the opposite direction, we'll call this as F1. So at every contact surface there exists a normal reaction. Okay, there exists a normal reaction. So this is N1, this is N1, this is your x-axis, this is your y-axis. So I'm just drawing this x-axis here, x-axis here, this is y-axis, so this is y-axis. Tension force acting along positive x-axis, tension force acting along positive x-axis, F2 acting along negative x-axis, sorry, F1 acting along negative x-axis, F1 acting along negative x-axis, N1 acting vertically upwards, N1 acting vertically upwards, or you can say acting along positive y-axis. Now this 750 weight, we know that weight will be acting vertically downwards. So this is 60 degree, means the angle made by this is 60 degree. So it is acting in the third quadrant. 750 angle is 60. So this is cos component, this is sin component. 750 cos 60, 750 sin 60. So the first condition, summation is equal to 0. So plus t, 1 second, okay, plus t minus F1 minus 750 sin 60 is equal to 0. And second condition, summation of vertical forces is equal to 0. Plus N1 minus 750 cos 60 is equal to 0. So N1 is equal to 375. Third condition, mu is equal to F1 by N1. Mu is given as 0.20 at all contact surface. So from this, F1 is equal to 75. Once you get the value of F1 using this equation number 1, T is equal to 724.5. Okay, so here the bodies are connected to each other. So first we have considered this 750 Newton block. Okay, and we have drawn the free body diagram. So here is the free body diagram. This is your x-axis along the parallel to the plane. This is your y-axis, so x-axis, y-axis. So tension force exists in every flexible material acting away from the joint. So this is a tension force, so this is a tension force. As the motion is taking in this direction, frictional force acts in the opposite direction. So frictional force, normal reaction acting vertically upwards, so normal reaction acting vertically upwards. 750, the weight will be acting vertically downwards. So this is weight, angle made by this is 60 degree with horizontal, angle made by this is 60 degree with horizontal. We have solved the equation and we got the value of F1 and T. Next we'll consider FBD of 500 Newton block. So you can see here, so this is a FBD of 500 Newton block. As the motion is taking in this direction, okay, so frictional force acts in the opposite direction. So this is the direction of friction. This is P, that means this is P cos 30, this is P sin 30. Okay, as you can see here, as there is a rope here, in rope exists a tension force acting away from the joint. So tension force acts like this, acting away from the joint. So tension force acts in the opposite direction. Okay, so this is 500, and that is weight will be acting vertically downwards and normal direction will be acting vertically upwards. The same I have drawn here in the axis. So x-axis, y-axis, N2 acting vertically upwards, T acting along negative x-axis, F2 acting along negative x-axis. This is P cos 30, P cos 30, P sin 30, P sin 30, and weight is acting vertically onwards. Again, first condition, summation is equal to 0. P cos 30 minus T minus F2, that is P cos 30 is equal to T plus F2. Summation V is equal to 0 plus N2 plus P sin 30 is equal to 500. So N2 is equal to 500 minus P sin 30. Mu is equal to F2 by N2. So mu is given as 0.20. F2 is equal to what? F2 This is F2 by N2. So F2 is equal to P cos 30 minus T. So P cos 30 minus T. N2 is equal to this. Solve this equation. We'll get the value of P as 853.5. Okay. The solution is very simple. Only you need to understand the concept here is first we need to consider the inclined block to find the tension force. So this is a free body diagram. So block is here. The weight will be acting vertically. One second. The weight will be acting vertical downwards. So this is 750. This is 60 means this is also 60. Tension force acting away from the joint. So motion is taking in this direction. Frictional force acts in the opposite direction. Normal direction will be perpendicular to the contact surface. So it is acting along positive y-axis. Okay. This is a coordinate system or the coordinate diagram. This is a simplification of the equations. Next second we'll consider 5 Newton block. The same we'll draw here and we'll use this equation. We'll get the value of P as 853.5.